Hi students, it's Dr. Marks and we're going to be adding on to our discussion of dummy variables. But now we're moving on to categorical variables, where I can't just use one dummy variable to capture the qualitative information that I want to put in my regression. So let's get started. Remember, as we've already talked about, dummy variables can be incorporated into our regression analysis. And we've worked with some simple examples already. For example, in our last lecture, we looked at male versus female. And if you have a variable where you're simply asking male or female and no other options, not non-binary, or I would prefer not to say, if there's only two states of the world here, then we know we incorporate only one dummy variable that captures this information. So if all I have is two states of the world, it only takes one variable. Remember, one less than the number of categories. But sometimes qualitative information requires multiple categories. And so one of the examples that we've already introduced of qualitative information that probably can't be summarized in simply two states is marital status. Now, yes, we looked at the example married, yes or no, in our last lecture. But if we really wanted to accurately capture marital status, we probably want married, widowed, divorced, separated, and single, never married. And if I want this kind of information, then it's going to take more than one variable to capture this. So in this case, we have 5 different categories. One variable is not going to do it. In this case, I need, remember, there's always one less category. So I have 5 minus 1 gives me 4 variables, right? And so this is what we mean by categorical dummy variables. These are our categorical variables. And so in this lecture, we're going to look at some examples of categorical dummies, and we're also going to practice interpreting. So we're going to look at some studies done by other people. But as a review, we're also going to look at some situations that require a single dummy, which we already did last lecture. So we're putting them both together, and we're going to look at some real-world studies and make sure that we can recognize where are they using a dummy variable, where are they using a categorical variable, and we want to be able to look at significance. So let's review the idea of dummy variables. So in this example, I've got a bunch of different employees, Frank, Steve, Cindy, Stephanie, so on. And we see that if we want to capture simply male, female, where those are the only two options, you don't get the option to say, I don't want to disclose, you aren't collecting information on if somebody is non-binary, for example, just 2 categories, then we already understand that this requires just one variable. So if you look at my table, I don't have male and female. At this point, you should remember why we don't have male and female. Do you recall that if we have male and female, then those 2 columns of data are going to be perfectly correlated, right? Because for Frank, it's going to be 1, 0. And for Cindy, it's going to be 0, 1. Anytime it's a 0 in the first column, it's going to be a 1 in the second. Anytime it's a 1 in the first column, it's going to be a 0 in the second. And we can't run a regression with both of those variables. It will either give us an error message or our software package is going to drop 1. But it would be better for us just to remember we only need one variable here. But then we want to capture marital status, and we have 5 different options. But we remember that we have to drop one of those, so we have one less category. And so hopefully you see that single or never married is our baseline. Now we can easily construct this data set. If we know that Frank, Cindy, Tasha, David, and Dana are married, then we would put a 1 in that column, but they get a 0 for everything else. So you see here, I've coded it for example, Frank, 1 for married, but he's not widowed, separated, or divorced, so those are all zeros. Let's say we know that Steve and Todd are widowed. So again, we would put a 1 in the widowed column, but we see everything else gets a 0. So if we're looking at Steve in the second row, he's not married, that gets a 0. He is widowed, that gets a 1. He is not separated, it gets a 0. And divorced gets a 0. So then from this information, can we read this complete data set correctly? Who is separated here in our data set? Well, let's look at the column for separated, which I have outlined for you. Do you agree that Stephanie and Charlie are separated? And I don't need to know anything other than being able to read this format, right? So I have two people that are separated, and we can ask the same question, who is divorced? Well, we see that the only person who's divorced is Parker, because he's the only one with a 1. And everything else in the categories related to marital status get a 0. Now, can we figure out from this data set who has never married? Who is basically in that baseline category? So remember, the omitted category is never married, and that's the baseline for comparing the others. So can I figure out who has never been married? So take a second, look at this, and see if you can figure that out. Do we agree, guys? It's going to have to be the row with all of the zeros, right? Because it's got to be somebody who was never married, never widowed, or they're not widowed. Sorry, they're not currently married. They are not currently widowed. They're not separated, and they're not currently divorced. And I only see one person like that. So Adrian. Adrian must be single or never married. But that's our omitted category. This is why, if you recall from an earlier lecture, and probably you don't remember, but remember we said we don't need that the fifth category, because the computer understands that somebody with a 0, 0, 0, 0, well, they're going to be in the omitted category. Let's look at some real studies that I found online. And so the first one I found looked at reforestation after a disturbance. And this was in Nature Communications. Now, we don't need to understand a whole lot about this study to be able to understand this. So we're looking at different parts of the world and how well they reforested after some kind of environmental disturbance. So as you see in my yellow box, we're collecting data on the amount of recovery after some kind of environmental disturbance. Now, as you see, there are 4 geographical categories. We have Africa, Central America, South America, and then an omitted category. Well, I took a quick look at the study. The omitted category is Asia. So Africa, Central America, South America, and Asia. And they're using Asia as the omitted category. So can I determine that just from looking at the table? No. I had to read a little bit about the study and figure out which was the omitted category. And of course, when they're writing up a study, they're going to tell you who the omitted category is, because that's how you would interpret. Remember that because Asia's our omitted category, we're going to interpret relative to Asia. So let's look at Africa here for a second. Do you agree that we see a significant positive coefficient for Africa? So take a second and make sure you agree with that statement. So coefficient is 0.856, right? It's positive. And remember, we've got a p-value of 0.009. So the probability that this happens simply by chance, that we got this conclusion when we shouldn't, is not likely at all. So we have a p-value of 0.009. So what that tells us, since we have a positive coefficient, that recovery was better in Africa, but better than who? Again, relative to Asia. Why? Because Asia's our omitted category. Remember, when we have dummy variables, everything is translated and interpreted relative to the omitted category. Now, we can't really interpret this because I didn't read the study closely enough to figure out what exactly is the method for measuring. I don't know how you measure reforestation, and I'm not interested at this point in going that far into this, but the next step would be to interpret 0.856. But I can't do that accurately because I'm not going to lie, I didn't read the whole study to know with the detail we would need. But right now, I just want you to understand how to recognize that there are categorical variables. And again, we are reviewing how to look at significance. Now, what about South America? Take a second and look at South America and determine what you would conclude about South America. Well, we see a p-value of 0.265, right? A p-value of 0.265. So do we agree then it's not a significant result? It's not a significant result. Remember what it means to not be significant. And this is where students kind of get a little confused. It means that we cannot claim that that coefficient, 0.252, is really different from 0. In other words, it says 0.252, but really there's not enough evidence to say that that's any different than it actually being 0. So this is not a significant result. So what that would mean then is that recovery is no different in South America than Asia. Remember, we always have to compare to the omitted category. What we can't really conclude is, well, how does South America compare to Central America? How does South America compare to Africa at this point? Because again, this categorical variable is simply allowing us to compare to our omitted category. Now, there's other things we could think about, but we're going to keep it simple right now. There's also a second set of categorical variables in this study, and you see them right there with my red box, and it's related to the type of disturbance. So not all environmental disturbances are the same, and this study had 4 different categories of environmental disturbance. Remember, one gets omitted and it becomes the baseline. And again, I don't know much about the science behind this, but what I can look at and see is that category U is significant, right? We have a p-value of 0.007, which means there's just about no chance that this is a coincidence, that we have this kind of information just coincidentally, by chance. It's suggesting that we have a lot of evidence that that coefficient 0.936 is not equal to 0. And so, if I knew what the omitted category was, we'd be saying, look, this disturbance category U matters in relation to what we're seeing with other disturbance categories, the omitted category, that the rate of deforestation is different when the disturbance is in category U relative to when the disturbance is in the baseline. All right, let's move on to another example. So this study right here is looking at number of children per family. And it's specifically asking the question if number of children is tied to wealth. Do wealthy families versus not wealthy families have different numbers of children? And so this author used a categorical variable in this example to capture the different wealths. So 5 categories: poorest, poorer, middle, richer, and then richest was the 5th category. So richest is the omitted category. Now again, this is just, I think, a classroom example. This was not a study that was done, because hopefully you're thinking, well, gosh, wait, shouldn't there be some other variables here for control variables? Absolutely, there should be some control variables, but this was done just as an example, I think, for a classroom use. So don't worry about the fact that there's no other control variables. We are just focusing on these 5 variables, 4 of which appear in the regression. So again, as we interpret, we need to remember that our baseline category is the richest 1/5. All right, the richest wealth category. So let's see what we can learn. Again, remembering, interpret relative to the richest quartile. So what can we say about the poorest quartile? Well, let's see what our regression results tell us. Does everyone agree that it's not significant at the 95% level of confidence? Take a look and make sure that you agree with that conclusion. It's not significant at the 95% confidence level. Well, how do I know that? I'm looking at the p-value, and the p-value is 0.089, right? So while this result is not significant at 95%, it is significant at 90%. So I can be 90% confident in the result, but I can't be 95% confident in the result. All right. Now, let's interpret the coefficient. You see the coefficient 0.044 in that very first column. So what this says is relative to the richest quintile, people in the poorest category have 1.04 more children. So let's look at that again. So we know it's significant at the 90% level, which is not as strong as we want it to be. But with that level of confidence, we're saying that relative to the richest quintile, which is the part that is left out, right? That's the omitted category. Poorest families have 1.04 more children. And this would be all else constant, but I don't see any other control variables in here, but maybe there are some and they're just not being reported, so I'm not sure. But we do understand that this is not a very strong result, right? That p-value of 0.089 means that we're only significant at the 90% level, which means we're only 90% confident. We'd really like to be a little bit more confident. We'd like to have a little bit more evidence against our null hypothesis. Now, what can we say about the next category, which is poorer? So take a look at that for a second. So everyone take one moment and see what conclusion you would come up with for poorer. Well, hopefully you realize that it's not even significant at 90%. It's not significant. So 90% is not a super high bar, and it doesn't even clear that bar, right? Now, how did we know that? We looked at the p-value of 0.121. And so we can only be, like 87% confident from this? So think about what that means in terms of our hypothesis test. There's not much evidence that we can reject the null hypothesis, right? That our beta equals 0. So we cannot reject. Remember how we express that. We used the terminology, we fail to reject H naught. Please do not say we support H naught or we accept H naught. The language we need to use in statistics is that we fail to reject H naught. In other words, there's just not enough evidence to claim that we can reject H naught. And H naught, remember, is that our coefficient is equal to 0. Now, I know that's kind of weird, right? Because you're looking at the table and you see a coefficient 0.5858793, right? But just because our regression spits back a coefficient, that doesn't mean it's significantly different from 0. And so what we've just concluded is that that coefficient is not significantly different from 0. That means, with respect to our study, we would say that there's no significant difference in the number of kids between families in the poorer classification and in the richest quintile, right? That we can't say there's any statistical difference, which means number of kids for families in the poorer quintile and in the richest quintile do not statistically differ. The next example is looking at credit card debt. And so this is a data set on individuals' debt levels and credit card debt levels. And there's a number of control variables in this study right here. So you see all those variables on the right. First, what dummy variables do we see? So take a look right there, and you agree that all the other things are continuous or non-dummies, right? Income, your credit limit, your credit rating, probably cards means number of credit cards you have, your age, education. But the ones in the box are dummy variables. So we have gender, and it says gender female. You could just call it female if you want. You don't need to call it gender female. But gender, if female. And then the next one is, if you're a student, if you're married. And then there's some categorical dummies, right? We've got Asian, if Caucasian, and then there's an omitted category as well. So let's hone in on those categorical dummies. Here we have them right here. So we see that we have two ethnicity categories in our regression model, Asian and Caucasian. But remember, there's actually a total of 3 because you have to have an omitted category. And so hopefully you're asking, well, what would our omitted category be here? Well, maybe it's African American, or maybe it's other. I don't know. But we've controlled for if you're Asian. We've controlled for if you're white. So it's got to be something other than those categories, right? Now, you might be asking yourself, why would they have set it up that way? Probably the data set would have had more people who were Caucasian, so why not make it Caucasian? You could definitely do that. And we're going to talk in a minute about how do you choose which category is the omitted category. But for whatever reason, this researcher decided to leave the third category, which could have been African American, or it could have captured all others, which would be Hispanic, African American, etc. I'm not sure. Now, does being female relative to male impact debt? Let's take a look. So take a look at that for a second and decide, does being female as opposed to male impact debt? What's your answer? The answer is no. Being female doesn't impact debt relative to being male. Look at the p-value of 0.3396, right? We don't have a lot of confidence that we can make this claim. So what we're saying is, look, females do not have any more debt than males. They don't have any less debt than males. The level of debt, holding all else constant, by the time we control for all of these other variables, gender has no effect. What about being a student? And remember, this is going to be the effect of being a student relative to being a non-student. Does that impact debt? Take a look. The answer is yes. Being a student does seem to matter. Now, we have a p-value here that's kind of expressed a little weirdly. It's actually 0.000000000. It just goes on and on. It's teeny tiny infinitesimal. So that 2e to the negative 16, think of that as like putting a whole bunch of zeros after the decimal. So when you see something expressed like that, that is Clearly going to be a p-value of 0. So highly significant, right? It's significant at the 99.9% confidence, right? So let's think about what this tells us. How do we interpret this? Everyone agree that if you're a student, you're going to have $426 and some change higher debt than somebody who's not a student. Let's say that again. A student has $426 more debt than somebody who's not a student, holding all else constant. Does being Asian, relative to whatever the omitted category was, does being Asian impact debt? Take a look at that. Does being Asian impact debt? Well, let's look at that p-value of 0.2333. This is not a significant result, right? We fail to reject our null hypothesis. So we cannot claim that being Asian relative to our omitted ethnic category, we can't claim that being Asian has any impact on debt relative to our omitted ethnic category. So again, even though the estimate is 16.85, we don't have enough evidence stacking up to say that this number is really any different from 0. Now, does being Caucasian relative to the omitted category impact debt? Again, the answer is no. If you look at the p-value of 0.4483, you see that, look, we can't be very confident at all here. And so even though we have a coefficient of 9.29, we can't claim that that's any different from 0. Again, we fail to reject the null hypothesis. And the null hypothesis is that our coefficient, our beta, is 0. So that would not be a significant result either. Now, what about income? Now, we agree, even though this is a lecture on dummy variables and categorical dummy variables, this is not a dummy variable, but it's still worth taking a look at. So does income impact debt? Well, what do we think? What's our p-value, right? We see that 2e to the negative 16, so 0.0000000 whatever, right? Clearly, this is highly significant. It's very strong evidence against the null hypothesis. Again, remember our null hypothesis is that beta equals 0. We see that this is highly significant, right? So we can interpret this. Remember, if it's not significant, the coefficient's like being 0. We don't interpret it. But here it's highly significant. So what we're saying is that for every, I don't know if it's $1 or $100 increase in income, because the study has to tell us what constitutes income, how are they measuring it, but we see that debt goes down by $7.8. So I'm guessing this is maybe for every $100 in income, every $1,000 in income, probably 100, debt goes down by $7.8, $7.80. So again, if I really want to know how to interpret income, I need to go back to this study and see how they measured income. Was it total dollars? Was it number of hundreds of dollars? Was it in thousands of dollars? Like if you make $50,000, maybe they put in 500 or maybe they put in 50. But right here, we just want to understand that it's highly significant. And we also want to understand that income is not a dummy variable. It's a continuous variable. But I just threw it out there so we could take a look. Now let's talk about setting up our categorical variables, because there are some key things to remember. Hopefully by now you understand that you need one less category. If there are 5 options, like there were for our marital status, married, widowed, divorced, separated, never married, then you need 4 variables in your regression. The next thing we've said over and over again is that you interpret the other categories, the ones that are in your model, in relation to your baseline. Your baseline is that category that has been left out. So let's say I omit the category of never married, and I use the 4 other categories. So never married, that's my omitted category. Then everything that's in my regression, I interpret those effects of being married or being widowed, whatever, relative to never having been married. So you really need to make sure you are interpreting correctly and you're interpreting relative to your baseline. Now, which category should we leave out? We made a mention of that with respect to one of the other studies. And so it doesn't matter statistically. It really just depends on what you want your baseline to be. But theoretically, statistically, it does not matter. Your regression is still going to run, but it does impact your interpretation. So you need to give that some thought. Maybe there's a hypothesis that you want to test, and if there is, that's going to drive your categories and which one's omitted. Maybe you think unmarried people have lower debt per person than others. So if your hypothesis is that unmarried people have lower debt, then maybe you leave that category out. Remember, then everything else is going to be evaluated relative to somebody who's unmarried. So if others have significantly more debt, then you would see positive coefficients. So you're trying to see if others have significantly more debt. Are those coefficients, those betas, positive, right? Relative to being unmarried. If you don't have a hypothesis in mind, then maybe you choose the category with the largest number of observations. So in this study, where they controlled for the different ethnicities. Remember, they had an omitted category that was, maybe it was black, maybe it was all other. Not clear. But maybe in a study you do, if you've got kind of more of a predominantly Caucasian or white population, maybe you make that the omitted category. Let's say it's reflected in 65% of the observations, then it might make sense to choose it that way. And that way, other variables are interpreted relative to a white student, a white worker, whatever it is that you're investigating. So choosing it on the basis of kind of what your data looks like. In other words, if you only have a handful of observations of a certain race, you probably wouldn't want to choose that as your baseline. That would be kind of a strange baseline. Or you could choose something on one end of the spectrum if it's a spectrum. Now, marital status doesn't really have a spectrum or an ordering, so there'd be kind of no spectrum to think about. But think about the study on number of kids, right? There were 5 income categories. That is a spectrum, right? It went from poorest to richest. And so the study chose to leave richest, right, the highest part of the spectrum, as the omitted category. But they could have also have done poorest, the other end of the spectrum. That would be fine. But it would be kind of weird to leave out one category like in the middle, right? That middle category would be maybe a little weird as a place to omit. So I like thinking logically about what your omitted category should be. So the message is either it's because there's a predominant category in your data, or because you're looking at a spectrum and you're choosing the end of the spectrum, or because you have a hypothesis, but you have to give thought to it. Don't just randomly choose a category to omit. That would not be good methodology. So let's recap. If you understand dummy variables, then you understand categorical dummy variables, right? They basically work the same way. You just have to think about having one less group. Remember what is called the dummy variable trap. And the dummy variable trap is that you always have to have one less category, right? For male and female, we just used one dummy variable, one less category. For marital status, we had one less category. Otherwise, you have perfect correlation between categories, and it's not going to work. You cannot run a model that has two variables that are perfectly correlated. So that's why, again, male, female, we only needed one variable. And if we have three categories instead, maybe instead of just male, female, I want to give people the option to say I'm male, I'm female, or I'm non-binary. If I have three categories, then I need two out of the three. And you should think carefully about which one should be the omitted category. Now, if you were looking at male, female, non-binary, it might be weird to make non-binary your omitted category because I'm guessing that it's not going to represent a huge portion of your data set. So probably you would choose male or female, and there might be some logic to which one, male or female, depending on your study. But either way, you need two out of the three. Again, otherwise you have perfect correlation between categories, and you cannot estimate it when you have that situation. As we've already mentioned, it's a violation of the classical assumptions. Now, some software packages will throw out a category to solve the problem for you. So some software packages are smart enough to know, okay, wait a minute, we can't have both of these variables. We're going to throw one out. But it's better for you just to remember this idea of the dummy variable trap and set it up yourself. Set it up the way you want it. Set it up the way that it's going to make the most sense for your particular study. So gang, let me know if you have any questions at all. Thank you for listening. And again, I hope you have a fantastic day.